Curtin University researchers have helped uncover evidence of a mysterious giant asteroid impact hidden not in a crater but in tiny pieces of glass found only in Australia. Co-author of the research paper published in Earth and Planetary Science Letters, Professor Fred Jourdan is beaming in. Professor, welcome. This discovery centres on rare tektites. What are they?
A tektite, they are just a little bead of glass that have been produced by a giant impact. Well, giant from our human perspective, few kilometer in this case, up to 25 kilometer, and so there's an asteroid coming and hit the ground, and the shock is so hot you can imagine like a nuclear explosion or something like that, and it vaporizes the ground, but also melt a part of it. And those little molten piece of glass, they just shoot in the sky and fall back. And as your picture is showing, they tend to end up in a little sphere because during their journey in the atmosphere, they freeze. So if a piece of lava, if you want, it's ground lava, is cooled slowly, it's going to produce crystal. But if it's quenched very rapidly, it's going to produce glass.
Well, these newly discovered type of tektites have so far been found exclusively in an area mainly within South Australia, an area unique because of their unusual chemistry and their 11 million year old age. Why are those two things significant?
Well, I mean, every tektite almost that you find in Australia, it's about 780,000 years old. It's called the Australasian tektite with an impact crater that we don't know exactly where it is yet, but probably in Indochina. Fine. But in the collection that you can find in the museum, you can find some that have a different composition. And people really didn't know if it was part of the same tektite field, originating from the same crater, if you want, or if it was from a different crater. So the best way to do it is two things. You measure the composition, and in this case it was different, and you measure the age, and that's my specialty. And that was also vastly different. It was 11 million years old compared to, like I said before, 780,000. So obviously it tells us it doesn't come from the same crater. But those tektites, they are really rare. I think so far there's 14 pieces, 14 small tektites that have been found in a museum. So they all come from a strewn field which is about 900 kilometers long. So very dispersed, if you want, because there's only 14 of them, and dispersed like that, and collected over the years. Not knowing they come from a different crater, but with those analyses, we're like, well, that's completely different. And again, like in the case of the Australasian tektite, we don't know where the crater is. It's unknown.
I think that's the really fascinating thing here is that, as you say, it's been in the museum, thought to be part of this Australasian strewn event, but it's so much older, and we don't know where. It's kind of working backwards a little bit, isn't it?
Yeah, exactly. It's like a mystery puzzle that you need to solve, and you look at the clue. And in this case, the clue for finding the crater is the composition. I mean, when the asteroid struck the Earth, it melts certain target rocks, and rocks have different composition, but this composition is transferred to the glass itself. So when you analyze the glass, you're like, aha, it must come from this type of rock. Now we look at the composition, and it's different than the Australasian tektite, and it comes from a rock which is produced by volcanoes. But in Australia, we don't have that many volcanoes. We do near Melbourne. I studied them at some stage, as they're really, really cool, totally worth visiting. But they don't fit the bill. So you need a different type of volcano. Those ones near Melbourne, they are more like, effusive red lava, nice kind of quiet volcano, maybe a bit of fountaining. Those one, they are different type of volcano. They are the one that explodes with huge gray cloud of ash, and they are the one that you can find in Indonesia. So we think it might come from Indonesia or Philippines or Papua New Guinea, less likely from New Zealand. Now in Australia, there's a few rocks like that that are really ancient. It could be from there, but much, much less likely. I would love that the crater in Australia is in Australia, right? We can go and study it much more easily. But it might come from a different country. And if you've been to Indonesia, you know it's fairly wet, so there's a lot of forest. It could be covered. There's a lot of volcanoes as well, so it could look like a volcano. A crater is look like a crater. A lot of volcanic craters that have been misidentified for for impact crater, but they're in fact volcanoes. So disentangling the two require going in the field, taking some sample. So it's a very long process. Bottom line, we don't know where it is.
And why is it so important to study these ancient impacts?
Well, impact, I mean, everybody has heard about the case of the Chicxulub impact 66 million years ago, wiping out the dinosaur. But the wiping out was not because, you get a bunch of dinosaur and the asteroid come and on top of them and they get squished to oblivion. It's not that. What happened is like you had a big crater, it threw a lot of material in the atmosphere, it changed the climate. A few years ago, we had the Pinatubo eruption. That also, it's a tiny volcano, it's a small eruption, and yet it decreased the temperature by 0.2 degree, which doesn't seem much, but it's a single volcano in a tiny location. So those things, they can change the climate. Now, this one is probably up to 25 kilometers in diameter. But that's too small to create mass extinction. However, it can be very significant to change the climate of a region. So if people reconstruct climate and things, and they're like, well, what happened here? We don't understand the climate shift. It doesn't match our model. That's the kind of explanation we can get. So no need to reinvent the physics of the climate. There's a simple explanation. You get an impact that changes the climate locally. So that's why having all the pieces of reconstructing the past is really useful, because you avoid to go in wrong direction and you get, every single aspect that you can enter your model, your reconstruction, things like that. Also, finding impact crater is pretty cool because tourists love it. I love it. We get a few in Australia, like in Western Australia, we get Wolf Creek crater. A few years ago, there was I don't know if you've seen it, the horror movie.
Yes.
Yeah, you've seen it. So, this kind of stuff, I mean, capture people's imagination. I think it's pretty nice. So, yeah.
And as you say, it'd be really cool to have this crater here in Australia, because it's something else for our geological tourism, I'd like to call it. People would be coming everywhere and to have a look at this crater, and something that we didn't think was happening so many years earlier was actually around and impacting the Earth.
Absolutely. And the fact that it's so young, well, young by geological standard, 11 million years, it's like yesterday. It's like the Australasian tektite, 780,000 years. It's very much yesterday, which means that the crater is not eroded yet. So a lot of impact crater that we have in Australia, they are not called crater by geologists. They are called impact structure, because all the rim have been eroded, and what you find is only in the basement. You find the clues, there was a crater, there's no question here, but you don't see the morphological aspect of it. But those young craters, you can still see them. So yes, they are very propice for tourism, actually.
And it's also helpful to understand exactly what Earth's been going through in its life, and also potentially what's ahead. If there are a lot of craters, what's changed in our solar system? Are we at risk in the near future? We have these near-Earth asteroids heading towards us. Are we at risk? These are the things that we can learn and understand.
Absolutely. I mean, you can look at the past record. Always, geologists, we know that. Look at the past to understand the present. And we do that a lot for climate change. We understand how the climate get modified in the past. So now we can, we know what happened when you put carbon dioxide in the atmosphere and things like that. It's the same for crater. So, how often Earth is hit by a crater, and you can construct probability model that's like, well, there's a chance of a 1 million that a big one is gonna happen soon, or a small one, it's 1 in 10,000. So the smaller it is, the more chance you have that it happened. Remember Chelyabinsk in Russia a few years ago, where it gives people a scare and stuff. That was a small one. That was just only 10 meters. But it shattered a window. Russian people thought they were under attack, things like that. So you want to measure that. I happen to also work on asteroids themselves, studying sample from sample return mission from NASA or Japanese Space Agency. And I think the two of them, they connect nicely. You understand the impact record on Earth, but you also understand what asteroids are made of, how they react when they're impacted. Can we deflect them? Can we push them away? So a lot of those asteroids that we are at risk, they are the smaller one, because the big one, we can spot them. And I think, worldwide, we did a good job of spotting all the big ones. But the small one, and by small, I mean a few tens of meters, hundreds of meters, that they start to be really dangerous citywide. If it falls on the city where I live, Perth, it's game over, right? Even a small one, it's not. We're smiling and stuff, both of us, but it's not nice when you think about it. So what you want to do is, like, when they come, when you detect them, you want to understand what they're made of, so you know what to do. For example, I work on rubble pile asteroid. So they are made of bunch of rubble connected together by loose gravity. What we discover is, like, they can take a nuclear blast, but not inside them. So if you detonate a nuclear weapon on the side of the asteroid, it can take the blast without shattering and just being pushed away, which is pretty cool, because if it shatters, so great, it's not falling on Perth anymore. But now it falls on Beijing and Washington, and both of them, they're not gonna be happy with us. So there's a lot of obviously, problem with things like that. So you need to think about it very carefully. And what it shows us is not like, oh yeah, well, those scientists, it's wasted money. Personally, I think basic science is not a waste of money. Understanding how our solar system, our universe works, I think it's absolutely critical for humankind. But also there's an application, because it shows us it happened quite regularly. So we need to be prepared, not being like, oh, incoming, interesting. No, too late. So yeah.
Yeah, absolutely. And as you say, we do chuckle about the hypotheticals and those sort of things, but it's understanding what could potentially happen. And you hit the nail on the head there as well. And I hate people that say that it is a waste of money. It's not. It's, as you said, it's understanding what has happened, how often it happened. It changes the likelihood scenario as well. And how much should we be investing time and money into researching these type of things to make sure that we're safe. As you say, I mean, if an asteroid hits Perth, it's such an isolated city that Perth's going to be impacted. But there is a stronger likelihood, if you watch all of Hollywood movies, that America's going to be hit and the rest of the world will be safe. So that's kind of okay. But we need to work out what's going on, what's potential, and things like these tektite discoveries prove to us that what we thought we knew is always changing.
Yep. You nailed it. That's it. I don't have anything to add. This is exactly that.
Fantastic. Professor, this is fascinating stuff. Hopefully we find that impact crater. Hopefully it's in Australia. For now, though, thanks for your time on this Talkin' Science.
Yeah, I appreciate you having me. Thank you very much.
More science and space news with an Aussie flair in 2026, plus the occasional science fiction podcast. So like, follow and subscribe for more. Membership helps me do more, so get on board and help out for the cost of a cup of coffee a month. Thetrek.zone/support.